common approach on a problem like this is to find the order of the number of the base that you're interested in. Now, our base in this particular case is 6, and it's raised to the 33rd power. And we want to find out what the remainder is when we divide this huge number that's almost impossible to compute mentally by 125. Now, one of the key ways of solving a problem like this is finding the smallest integer k such that 6 to the k is just equal to 1 mod 125. Now, there's something called the Euler Totient function that you could try, but it returns 100. And then it turns out any order is going to be divisible. Any order will divide 100. But it turns out this one's fairly big. Now, let me just show you what you would go through mentally if you weren't familiar with Euler's Totient function. And again, why are we interested in this? Because if we can get k to be a reasonable size, we can just use laws of exponents to get this reduced quickly, because we have powers of 6 just being equal to 125. Now, let's just, to show what I'm trying to get at here, 6 squared is equal to 36. Okay, we're not above 125 yet, right? 6 cubed is 216, which leaves a remainder of 91. Right? Folks, see there, if you divide this by 125, you get a remainder of 91. 6 to the 4th would be congruent to 6 times 91. And what is that? 6 times 91 is 546. So you see how big these numbers are now? You'd have to reduce this mod 125. And I think the best you can do here is, 3 times 125 is, 375. And so 4 times 125, oh no, that would be 46, right? Is 4 times 25? Yeah, 4 times 25 is 500, right? So this would be congruent to 46, right? But you see how we're not getting close to 1 here, all right? And it turns out you have to go all the way to 25, which is a divisor of 100, okay? So let's look at another approach. And even if you just worked with that, you would still have 6 to the 25th. You would still have 6 to the 8th to reduce. All right, so what we're going to do is do a completely different approach. It's called the binomial theorem. And you can see it's very, very useful to consider this because you have this gorgeous 5 sitting here, which is the only factor of 125. Now, let's just write down a fact real quick we can write down that 3 to the n is congruent to 0 mod 125. Provided that n is greater than or equal to 3. And that's crystal clear, and no need to talk too much about that. All right. Now, most of the terms in this expansion are of exactly this form, which means the binomial coefficients aren't even relevant at first here. So there's 34 terms, 31 terms, 31 terms are 0. We can say congruent to 0. And it's understood that it's modulo 25, right? 31 of the terms. Now let's see, in the name of space, I ran out of time right here. Another term that would appear here would be the binomial coefficient 33, choose 3. And then 5 cubed. And you see that would make it the very last one that was congruent to 0. You see I have 5 squared right here, and that's why I left them. But owing to this very simple truth here, 3 to the n is congruent to 0, that's where this 0 comes from. It replaced 31 terms. Okay, so all we're left with is we need to reduce the binomial coefficients times these powers of 5. Now, let's see, the last part here is pretty easy. This is 165 plus 1. Okay, and then that's 166. And 166 is the same as 41. So this part is 41. It's congruent. Let me write it like this. Congruent to 41. And again, it's mod 125. So we got the last part down to 41. All right. So that's congruent to 41. Now let's look at this part, which is a little more involved. 33 times 32 divided by 2 is 33 times 16. times 25. Right? Okay, y'all. Now, let's see here. What do we get here? That's 16 times 25 is 400. Let's see, what does that leave when we do the arithmetic here? That leaves us with, we need to get that reduced, that particular number, 33 times 25. Now, oh yeah, y'all, this is 400 right here. This is 400. So 400, when you divide it by 375, leaves a remainder of 25. So this is 30, congruent to 33 times 25. Okay. Now, and again, y'all, does that make sense? 16 times 25 is 400. 3 times, if you drive 125 into 400, you have this remainder of 25. Okay. So it looks like the 16 just went away. It sort of did, but it is 16 times 25 happens to be congruent to 25 mod 125. Okay, now let's see. From the way I did this was 3 times 11 times 1 times 25. It's prime factorization of 33. Now, y'all, 11 times 25 is, let's see, is it 275? Yeah, 11 times 25 is 275. You divide 275 by 125, you get 25. So this would be congruent to 75. Again, you guys can check, but I've double checked this. I'm pretty sure I got this right. So this piece right here is congruent to 75 mod 125. We've already shown that this is 41 over here. So what we get right here is that it's 146. It's 75 plus 1. And y'all, sorry I didn't write that in quite, precise equational form. But, oh wait, that's 41, and what is that, 116? Okay, I got 116. Let me check my notes and make sure. That's what I got when I calculated earlier, 116. Excuse me. So that's the answer. Your remainder is 116. And again, folks, in this particular case, I think the binomial expansion is the best way to do it. Okay, I really do. I think it's the best way because it's not so easy to find k. Even with special results, you just have to, it's quite a while. It's a phi of 125 if you're interested. And that's easy just to almost do in your head. It's the number of values that are less than 125 that are relatively prime to 125. And that's 100. And that's pretty easy to see just without knowing any, you don't have to know Euler's Totient. There are 25 multiples of 5. And obviously they aren't relatively prime to 125. Okay, so that's why there's 100. And it turns out that our k happens to be equal to 25, which you'll note is a divisor of 100. But this doesn't, just because we know this doesn't make it easier to calculate this. And you can't really work with 100 when really 33 is what we're dealing with. And then even when you know that 20, and it takes some time to show 25. It's rather tedious actually to show that 25 is the order here. I don't know a quick, simple way to do that. But the binomial expansion to me is very, very nice in the sense that 31 of the terms right off the bat are just flat out equal to 0, and you're only left to do reductions on these last terms. And I hope this was clear, folks. I lumped all of this together and got 41. Then I did all of this right here. And I'm pretty, I double checked this. I'm pretty sure my stuff is right here. So anyway, I got 75 plus 41, which is 116. Okay, thanks for viewing.